Hi everyone. I think we will begin now. So welcome everyone. Thanks for joining us this afternoon. So welcome to PS21's Roadshow for SmartBot Challenge 2022. So during the roadshow, we will hear from our co-creators and co-sponsors, and also you'll get a chance to ask them questions later on. So in case you're unfamiliar with what SPC is, it's also short form for SmartBot Challenge, and it's a flagship event from PS21, which stands for Port Innovation Ecosystem Reimagined at Block 71. And it's a program co-founded by NUS Enterprise and MPA. So this year, we actually have 15 innovation opportunities, and we are supported by 22 maritime corporates. Yeah, so for the roadshow, the first hour we spent speaking with our corporates here today, and the next half an hour will be for networking for those who are present with us. Yeah, so this afternoon, we have representatives from ABS and Wilhelmsen. So thank you for joining us today. Yeah, so before moving on to our two innovation opportunities, maybe you would like to play the first video. Yeah, so could we get that on screen, please?
Additive manufacturing, AN, holds potential for the maritime industry, especially in built-to-order spare parts for vessels. By enabling on-demand layer-by-layer 3D printing closer to the user, the use of AM can reduce lead times and transportation costs, overcoming the challenge of spare parts inventory management. Given the potential of additive manufacturing in reducing downtime, streamlining inventory of spare parts, and ultimately contributing to the overall decarbonization efforts of the maritime industry, the uptake is fairly low. One of the key reasons is the uncertainty in the quality of these additive manufactured parts. Today's AM process requires multiple verification steps to ensure its consistency and repeatability, which uses traditional methods such as non-destructive testing, but are not optimized for new manufacturing processes such as additive manufacturing. Since it relies on the track record of experience of the service bureau. In order to streamline AM qualification process, the American Bureau of Shipping, ABS, is looking at innovative technological solutions to ensure consistent and repeatable quality in the AM process, so as to streamline AM qualification processes. These technologies may leverage the power of data to improve decision-making during qualification.
Okay, so I think we can move straight ahead into our first innovation opportunity, which is how might we attain consistent and repeatable quality in the AM process so as to instill confidence and adoption in the maritime industry. Yeah, so maybe if you don't mind, maybe you could share your name, a little bit about what you do, what your company does, as well as you can hit into the innovation opportunity. Yeah. Okay.
So maybe I'll start. So my name is Wenjin. I'm from American Bureau of Shipping. With me, I have Qingzhen. We are from the same department. So basically, American Bureau of Shipping, or ABS in short, we are a classification society. So for those who are unfamiliar with the maritime industry, classification society is the main certifying body for all the vessels. So whenever we do a vessel, we call them a classed vessel. They will carry ABS's mark or logo. So in this case, for additive manufacturing, we have identified it as one of the emerging technologies. In the sense, I think from the industry, the entire maritime industry, there's a lot of potential for the technology. But today, the approval and certification process is very much still catching up with what the technology is all about. So we've been identifying what are some of the gaps that are necessary to be closed. And one of them would be on quality assurance. So later on during the conversation, feel free to ask any questions on how the maritime industry works, for example, what are the requirements, and what are some of the things that we have identified. We'll be more than happy to also address them.
Hi everyone, I'm Daniel from Wilhelmsen. So I'm from the 3D printing venture. Wilhelmsen, if you know the name, it has 50% of the global merchant fleet as our customers. So we are very well versed in what are the needs of our maritime customers. For me, I come from this special arm called Open Innovation, where we look at new solutions and services to shape the maritime industry, how it's working today. In the 3D printing venture specifically, I look after the digital platform that we host, all our digital files, and how we route it through our fabrication network in order to fabricate the part. But you can imagine it's not always that simple. You can send digital files, you can send data, but how does it map to the physical part? That's the challenge. And this is something you are interested in solving, or at least putting more assurance on the part. At the same time, I also look after the fabricator network. So qualifying them to produce our parts, make sure that they have the right track record in order to fabricate the industrial parts that we need. Yes, thank you.
Okay, maybe I could start off the first question. So just wondering, maybe you could explain a little bit more on how it's currently done, how the quality assurance is currently done for additive manufacturing.
Okay. So I'll probably provide some insights in terms of the approval and certification perspective.
Yeah.
So today, I think we rely a lot on traditional means. So today, how your typical parts have been certified, the kind of methodologies that you use, it's very similar for additive manufacturing. There's not much changes. And I think that is why we have also identified this as one of the potential or opportunity to improve. So this includes a lot of reviewing of your drawings, reviewing of your manufacturing processes, looking at your quality management of the entire manufacturing facility, and then doing a lot of mechanical tests to really ascertain the mechanical properties, whether they match the requirements, whether they match what are in your manufacturing procedures, looking for things like, are your operators qualified? And then eventually, after the entire manufacturing process, what are some of the controls in place to make sure that you maintain that consistency in the quality before you actually deliver out to your customers. So actually from ABS perspective, we have also come up with a guide, so we call it Additive Manufacturing Guide, that has been published to actually help our clients. So any clients who are keen to look at using additively manufactured parts in the maritime space or the offshore space, they can just refer to this guide. It contains all the current requirements or the things that they need to do before we can approve them. And they're able to then get their parts qualified by us. Yep.
Hi, just to add on to what Wenjin has just shared. So traditionally, how do we qualify parts from a traditionally manufacturing process? We do disruptive testing, we do non-disruptive testing. So this is something that for now also applies to the AM parts as well. So whenever we print something, we will need to make sure that the quality is as is intended. So what we do is we also do a lot of testings, and some of the testings they are repetitive, some of the testings might or might not be necessary, but from our perspective, really for us to think of ways that we can assure the quality of the printed parts in the most effective way, especially for the AM parts itself.
Yeah. So a bit more about, so for us, we produce parts. We have produced like hundreds of parts for end user customers. And what we do is to classify all our parts. Let's say we have a fabrication job. We will assess the criticality of the part, class 1, class 2, class 3. For the high critical parts, definitely we'll follow the class guidance in order to get it certified, do the necessary destructive and non-destructive tests. So that will be done. But there's another class of parts for less critical parts, which might not need to go through that level of rigor. And therein lies also the difficulty, the challenge. The challenge is that working with a global fabrication network means that there are different entities who will be involved in the fabrication process. And it's difficult to qualify through all these different fabricators on what the output would be, is differing quality. If let's say there is a digital means, for example, in order to make sure that each and every part of the characteristics of the part is guaranteed, that would really help in the fitness for purpose of the part onto the vessels.
Thanks for sharing. So maybe you could share on some of the challenges that our solution providers might face when they're trying to solve this problem. Yeah.
Okay, so maybe I'll kickstart. I think as what the video has mentioned, and also what I mentioned just now today, for quality assurance, a lot of them are based on the traditional means. So it means a lot of physical testing, a lot of coupon testing. But then that defeats the purpose of additive manufacturing. So in additive manufacturing, what we're trying to look at is on-demand printing, so that we actually can get parts at a very quick time. So for spare parts, especially those with long lead time, we have seen a lot of industry cases where they have actually shifted to look at exploiting AM technologies, because it reduces the lead time by a lot. However, if let's say we start to then look at all the physical testings that's required, it actually lengthens the entire lead time. Plus, it actually also increases the cost, the overall cost. So imagine today, if let's say I have a spare part that costs maybe $100. Now, of course, $100 is from the stockists, but then if let's say I want to additively manufacture it, maybe it costs slightly more, maybe $200. So from a lead time perspective, paying the extra is okay. But then because of the additional cost for coupon testing, you actually have to pay maybe $500 for a $100 part. So then the business case actually is not so strong. So I think what I've presented just now is probably some of the use cases that I've come across. There may be other use cases that's out in the market. But more importantly, we have also identified that there has been an advancement in terms of the technologies for quality assurance. Meaning today, people have also managed to look at, okay, I can actually reduce all these physical testings. I can actually use a certain test to replace some of these physical testing. And some of these tests could be from the process itself, the AM process itself. Instead of doing actual physical tests, I'm able to extract data. And then from the data, I'm able to correlate that, hey, actually the properties are as such, as such, as such. The thing is, these innovations have not been formally put into any approval or certification process. And I think that is where the gap is. And that's where today, when we are talking about this technology, we are hoping to get these technological solutions to be identified or recognized by the approval and certification process, such that we are then aligned to what the industry is currently practicing and what the industry really needs in terms of advancing the adoption of the technology. So that's from our perspective. Yeah.
Maybe I share a bit more. So first of all, I mean, I would say kudos to the class societies like ABS, really finding a very pragmatic way in order to qualify the parts, which we fully appreciate. Yeah, because producing an AM part, what the end users really want is to benefit from the low lead time. So having all these streamlined processes really help. And I think the class societies are improving day by day. So that's wonderful. In terms of challenge, I would say it's really mapping out how do you translate a digital part into a physical part with the same amount of fidelity. So there are solutions out there that we have explored before, things like blockchain, your NFTs, that can sort of restrict the part and to count how many times, for example, you print through a machine. So these are valuable technologies, but the downside is that some of these can be too restrictive. So there is know-how within each of the fabrication bureaus, and they need certain flexibility. For example, they might want to over-manufacture some parts because they know there will be some shrinkages. So locking down a certain design very strictly doesn't work. We know that. But how do we match the current solutions like blockchain or NFTs to make this a more practical solution? I think that's the challenge that we need to face.
Maybe at this point, I'll ask if there's any questions from the ground.
The process of certification or approval, do you have to make reference to like relevant ISO standards like 52900 or something?
Yeah, definitely. So in our AM guide, we actually specify what are some of the relevant standards that you may follow. And this covers everything from quality management all the way to all the technical requirements. So the answer is yes.
So the manufacturing facility would have to be certified to that standard?
Yes. So we typically require some form of quality management process in place. Having a certificate would definitely facilitate the entire process. If not, then our colleagues internally will have to then review all the documents that you submit. Yes.
Okay, maybe just one more.
Sorry, I can just add a little bit on this. So for example, in ABS itself, right, we have many different approval processes. So for example, typically for manufacturing plant, we have type approval, which actually requires a certain form of certification, for example, ISO. So this is something that is our baseline, but at the same time, you have to follow our own rules. So ABS, we develop our own guides. So our guides are also referenced from various different recognized organizations. So from the guide perspective, that is something that will always come and reference when we do the examination and also the certification itself. Yeah.
Maybe just two more questions. Yeah. On the approval process, does this come under the approval of external specialists? Sorry,
can you repeat again?
No, does it come under the same category as approval of external specialists for ABS?
Sorry, I don't understand the external specialist part.
External
I'm sorry.
specialists, you approve like people for servicing live rafts, servicing of fire extinguishers, diving companies.
So you're referring to maybe specialized operator qualifications. Is that what you mean?
Yeah, I believe this is the standard term used in ABS, right? External specialists.
Okay, my apologies for that. So for AM, we do require you to demonstrate your evidence of operator's qualification. However, there is no standard for that. So what we usually do is we will look for any evidence of training for the operator. Usually for the AM facility, manufacturing facility, these guys will be trained by the machine OEMs. And these machine OEMs will require certain number of years of frequency of their re-audit of their training skills. We also reference ASTM guide. So there's some ASTM guide in terms of what are the requirements when you want to do your operator qualifications. However, it is not mandatory that you need to follow ASTM guide. Yeah.
If I may just add one more question on the approval process.
Sure.
You mentioned about NDTs
yes.
and destructive testing. So would these follow the usual testing requirements for the original parts?
Yes. So currently, the NDT and disruptive testing requirements stated in the AM guide follows exactly what is used in the traditional manufacturing. So your usual tensile coupons, your visual inspection, your microstructural examination, your bending test, etc. The specifications are exactly the same. However, what is different would be things like how many coupons are required in your AM build. Where should you place the coupons? Like also what Daniel has shared, different categories of parts. The more critical components, you probably will require more coupons. The less critical components, you can actually eliminate some of these coupons. So from that perspective, actually it's all listed down in our AM guide. In fact, just to add on to that, what we're trying to do also is, if let's say we can, through this platform, identify ways to look at using advanced technologies to reduce the number of coupons, I think then that also serves as a very strong benefit to the industry. Yeah.
Okay, thank you.
Thanks for the questions.
Hi. My name is Nir. I'm the CEO of SciDome. We do cybersecurity for the maritime industry. I think that we all can see that the maritime industry at the moment receive a lot of digitalization very quickly in a way that I think that we didn't see in the last never. And I think that one of the things that we see in terms of manufacturing and class certifications, etc., societies, is that everything is a little bit in the past. We do not see, I'm coming here from maybe even criticism about the market. What we find today in vessels, I'm not going to discuss here, but it's in a very low level in terms of cybersecurity. I mean, today, all vessels are totally connected, everything. Even if a captain says, no, everything is disconnected, my engine is not connected, I can assure you that you can assure as well that it is connected in the end, maybe not 24 hours, but in the end, in some point, it will be connected. And the risk is just moving up and up and up. And in the end, I wanted to hear from you, how do you see it? But I don't see a lot of class societies that are trying to push cybersecurity. I see that there is some sort of certification for cybersecurity, but if a manufacturer decide not to do it, nothing will happen. So I wanted to know, how do you see it as a manufacturer and as a class society, that in the end, you guys are the ones that are making sure that all of us are working properly, right?
Okay, so from the cybersecurity perspective, I think we are recognizing that components are getting more and more interconnected, especially on the OT perspective. So the attack surface is increased drastically because of this. So currently for us, for our guide, so basically we also have a cybersecurity guide on that. So I think that is in terms of the notation, we actually issue a CS2 notation once you are comply with our guide itself. But from that guide perspective, it is to address for example, your crews on their readiness in terms of attacks, and at the same time from the equipment perspective. So I agree with you that cybersecurity is something that the whole industry is picking up. But from the class perspective, we are because we are looking for safety. So the OT side of the story is something that we are actually paying much more attention on that. We are reviewing on that. We are also, our guides are, as long as there is new things coming in, then definitely we'll go into review on that. So from the class perspective on cybersecurity, we are definitely looking at different attacks and different ways, and how we can make the ship a safer place. Yeah, so maybe also to Daniel to share a little bit on the manufacturing.
Maybe before that, I just add very quickly. So of course I concur with Chinkel because we are in the same department. So cybersecurity, definitely from a class perspective, we are definitely supporting the industry. But I totally agree with you that it takes two to clap. So more than just what we can offer, I think the industry, the various commercial entities needs to come together to really push for this. So actually what I'm pitching is also, if let's say over and beyond this session, if let's say you guys have any ideas for collaboration with any of the commercial entities, I think ABS is more than happy to support. Yeah.
Okay, yeah. From my perspective, I would agree. So therein lies the opportunity, right? Because there's so much space for us to implement digital solutions. And this is exciting for us. And we feel that part certification is one aspect that intuitively there's something that we can do. Yeah, because it's a digital part, how do you map it to a physical part? So on cybersecurity, there's this special aspect, just to share a bit further. We work with equipment manufacturers to onboard their designs onto our platform so that we can produce the parts on demand. And one aspect that will enhance their trust is in cybersecurity. How do we make sure that their IP is protected and not divulged? But at the same time, we do see like a different technology readiness, I would say, around the world. So a fabricator base, 24 hours separately, they will all have like a different setups within their bureaus. And this differing technology level impedes a common solution, a cyber solution to be implemented throughout. So these are some of the challenges that needs to be addressed when we implement any platform that connects to different bureaus around the world. Yes.
Thank you. Maybe I will just, for the rest, maybe an example about, we all agree. So there's nothing to discuss further, but for example, there's a very important system, the cargo control system, which is not supposed, obviously, it's an OT device. It's not supposed to be connected to the internet. You know how many times our system detect this system connects to the internet freely? A lot, and in a lot of systems that are already past the class certification. I mean, it's certified, everything is okay. And still the risk is so high in each of those systems, even if it's an OT and it's not supposed to be part of the IT. just to add even further an example. Thank you.
Can I understand a little bit more when you say that it already passed the class certification? Is it a cybersecurity notation specifically, or it is just a generic?
You're talking about the system that we detected?
Yes, yes.
Our system today, when we connect to system, we always check if there's a valid class certification. We see until which date it is, etc. They have some class certification. We cannot know if they're, probably they do not have cybersecurity classification. They have something about their hardware or something about the software. Mm-hmm. Some class certification have the system. But again, if a system is being used not by the way that it's supposed to be used, in the end, the class certification it's just a paper that is sitting there. It's not helping. The risk is still very high because this system is supposed to be offline. But if it has a Wi-Fi, for example, a Wi-Fi adapter, and the class certified didn't make sure that the Wi-Fi cannot be there because some human error, in the end, there are human behind it. So some human will connect because he is below the deck 8 hours and he wants to, I don't know, see movies, talk with his wife, I don't know. This is what is happening. In the end, the real world is in one place, and class certification, in general, ISO, all these certification, many times are not synchronized. I'm part of the ISO community, so it's not only a criticism about class certification. The ISO have the same problem, and we are working very hard to make the ISO much more strong. And by the way, I invite ABS and all the class societies to be part of the decision making in the ISO. Today there are two societies, the 27, which is cybersecurity, and the 8, which is vessels. An effort that I'm trying to do today is to create a new one, which will guide the maritime industry in one single united committee. I will help to know if you guys are part of the ISO and you can support this kind of movement.
Yeah, sure. I think we can definitely share more on this, but maybe we can give more opportunities to the rest as well.
Thank you very much.
Thank you.
Maybe I'd like to check if there are any questions on Zoom. Okay, so for those on Zoom, you can always keep your questions into the chat box. Yeah, so there are no further questions for this challenge statement. Maybe we could move on to the next challenge statement. Yeah, so could we have the video for the next challenge statement on screen, please?
Related to quality assurance in additive manufacturing is a robust adoption of digital warehouse. A digital warehouse is a concept where a common repository is set up to store digital files for all ship owners or additive manufacturing service bureaus, fabricating the parts on demand. Whilst there are some existing digital warehouse solutions available, the adoption level is low due to issues like security, the amount of effort in digitizing the inventory of marine parts. We are looking for an innovative solution that will increase the confidence in and adoption of a digital warehouse so that marine parts can be printed efficiently on demand and with assured quality. Some key considerations to note: cybersecurity. It's important that there can be no unwanted alternations to the digital files, as this could cause degradation in performance of the printed parts and lead to issues like safety and insurance claims. Intellectual property. There should be transparency on who owns the files and a way to manage usage by other stakeholders. Usability. Digitizing the 3D data should be fast, efficient, and accurate. Connectivity. End users should be able to access a wide network of printing service bureaus and marine parts files. Quality assurance. Finally, there needs to be assurance that the final 3D printed parts based on these digital files are what they are meant to be.
Okay, so for this second innovation opportunity, maybe Daniel, do you want to give paint a big picture on this?
Oh, thank you very much. Yeah. So I think Dr. Gu summarized it perfectly, and those are all very relevant areas. I would add that digital warehousing, storing data is easy. It's the easy part. Packaging them is easy, but how do we enable a process with our fabrication partners? What tools can we put in place in order to make sure that the physical part matches the digital part? So this is the real challenge. And yeah, if any startups can come up with a solution that can address that, I think that would be wonderful for everyone.
Actually, maybe just to add on to what Daniel mentioned, of course, whatever that was shown in the video is definitely accurate. And I'm just adding on new points. As an example, because Daniel talked about a network of manufacturers, right? So in our AM guide, we also have a certain list of requirements for manufacturers. And today, when we look at certifying these facilities, it's actually through a whole series of very traditional processes that is very consistent with how traditional manufacturing is. But what we are looking for today is really looking at, okay, if let's say we need to very quickly, rapidly qualify a lot of these manufacturers in one go because of the concept of digital warehouse, what is the best way to do it? Are there any solutions out there that enables a very efficient way of doing this that we as class, as the approval and certification body, is able to consider and hopefully develop a framework that actually recognizes these technologies? So that's something that we are looking forward to in this challenge statement. Yeah, of course, over and beyond whatever points that were brought out in the video. Yep.
Maybe you could share a little bit more on what kinds of solutions you have previously tried and maybe some of the gaps that arise from these solutions that are important to note.
I see. Okay, so without divulging too much info that I'm not supposed to share, maybe I can cite the example that I was talking about on the network of manufacturing facilities, right? Sometimes when we look at different manufacturers, today they can be using the exact same machine, exact same setup, exact same materials, powders, for example. The digital CAD files are exactly the same, the parameters are exactly the same, but then you get very different results. And many times we don't know what happened. So I cite you this example. So I was working with a company in the past. They had a manufacturing plant in the US. So they were very confident that AM is going to take off in Singapore. So they set up a manufacturing plant in Singapore as well. They brought the exact same setup to Singapore, but everything changed. Their parts came out. They were very confident that the parts would be very nicely printed, but their parts came out with subpar properties. And they realized that the climate in Singapore actually has a very adverse effect to that. Even though in their manufacturing plant, they actually had a lot of controls in place to control the entire environment, meaning the humidity, the temperature of the manufacturing plant itself is exactly the same as what was in US. So maybe it's not a manufacturing process issue. It could be the handling of the powders, for example. So what we are looking at in this case, for this particular example that I cited, what are some of the ways, the technological solutions that are very efficiently able to capture variance in the entire process, not just the manufacturing part, but it could be the handling, the storage. It could be through IoT devices that I'm able to very effectively capture this in the most automated way, such that I don't need human intervention, such that at the end of the day, when I'm trying to look at two separate facilities with the exact same parameters, as a approval and certification body, I'm able to confidently say that yes, without too much thinking, I can actually just straight away approve them. So that's something I felt that in the digital warehouse concept is very important, because in digital warehouse, what we're trying to say is you can store everything digitally and you can print them anytime at any of the service bureaus around the world. So does that provide the...
Yes, it does.
Okay, thanks.
Actually, just to follow up on that, because you did mention that everything sort of comes together, right? So what about ownership of these parts?
Ownership,
the IT side.
Maybe Daniel, you can take that.
IP side. Okay, in our venture, we are very clear that if, let's say, a part is owned by a certain manufacturer, we will not manufacture it without permission from the original design owners. So there's no problems if, let's say, we produce a part, people can be assured that the relevant party needs to be involved. And it benefits because the design owner would have the original designs, they have the original requirements, and we can fabricate it according to that specification. Yeah, but conversely, there are still some IP issues. For example, if, let's say, we send a design over to a bureau somewhere in the world, how are we going to assure that they only print once? Can they press play twice? Yeah, that would sort of infringe sort of trust within the the end users and also the OEMs. What we have done so far is to install very firm legal requirements to make sure that that doesn't happen. We also onboard qualified fabricators so that we can trust them to produce the parts. Yeah, but if, let's say, there's a surefire way that we can only press play once, then that would really help. Yeah, for the on-demand manufacturing of the part.
Okay, thanks for that.
Okay, so of course, what Daniel mentioned is from a commercial perspective, and then from an approval and certification side, we typically are very neutral on this. We do not provide any commercial advice. But I just want to add on the point about traceability. So what we'll be looking out for will be traceability, which is probably also related to ownership of the part. But it is in our blood to look at traceability, because if, let's say, anything goes wrong, we really want to identify where it came from, where does the problem arise, and then look at the entire chain to identify what could have went wrong. So if, let's say, we look at traceability, right, some of the technologies that I've seen out there for additive manufacturing, some of them actually introduce purposely designed defects into the AM parts. But of course, these are non-critical to the performance of the part. And then by tracing some of these defects, you're able to then go all the way back to the manufacturer or even the feedstock supplier. So this might not be entirely relevant to your question, but I thought I want to bring up the point about traceability and how it could be a relevant topic in terms of looking at this particular challenge statement.
I think it's a great point to actually bring up, so startups know that they should actually take this into consideration when building up a solution. Yeah, so actually what I'm hearing is that there are a lot of stakeholders that are actually involved in this. So maybe you could share some of the stakeholders that startups might be interested to speak to kind of get a better understanding of what's happening on the ground, people who are actually working with this on a regular basis.
Maybe I start with the approval and certification part. Okay, so I think the stakeholders, the relevant stakeholders can actually be referenced on the AM guide. So if you look at the typical process that we put into the AM guide, basically identify what are the things that we'll be looking out for, and this will be the stakeholders that are involved. So they could be anything from right from the start, which is the designers. So definitely designers, people who design the CAD models, they are definitely one of them. People who provide the material feedstock, definitely one of them as well. People who do any preparation work, and then of course the manufacturing facility itself. People who do post-processing, so this could be machining, heat treatment, and stuff like that. And then people who then eventually look at the distribution and licensing, for example. And of course, I would assume that for digital warehouse, it sort of covers the everything in the horizontal, whatever I just mentioned, in some way or another. So that's from my perspective.
Okay, maybe one more thing to add is that because we are talking so much on the AM guide that we have developed, so where to find it? I can just simply Google American Bureau of Shipping Additive Manufacturing Guide. Then I think the first or second search will be there. It's a PDF free for download for all. Yeah.
It's good that we don't have to pay for it. Okay, so I would say if there's interesting solutions out there, do come and approach us. We do control, at least the 3D printing venture that I'm in, we do control a large width of the processes, and we appreciate the different problems from the user customer perspective, where the demand comes from, what sort of data they provide, and what needs to be augmented. We understand that very well. And from the fabrication side, we have a partner, ThyssenKrupp, who is a supplier of engineering services. They do the design, and they appreciate the operations of fabrication machines as well. So they understand the problems and the pitfalls when it comes to producing parts through AM.
Okay, just want to pause here and ask if there are any questions from the ground. Yeah.
Okay, I think maybe from the Wilhelmsen side, maybe this will be relevant. The quality assurance process for the manufacturing process, is it possible for it to be extended to the life cycle of the AM parts in service?
As in to sort of weave in the traceability part, right? Because we do know a part, when it's put into operation, can last for very long, can last for maybe 5 to 10 years, right? And we are implementing the solution that Wenjin shared about traceability. So this helps us to do diagnostic on the parts. If let's say a parts fail for a certain reason, maybe 6 months down the road, then we know that a certain fabrication for certain characteristics of the part need to be enhanced, and then the design can be weaved in. If let's say a part lasts for 10 years, and we never hear about the serial number ever again for the part, it means it's a good use case. It fits well. Means the fabricator is sort of guaranteed. He can fabricate good parts for a certain profile of items. And within the platform that we enable, these diagnostics can be included. Yeah.
No, I was thinking more along the lines of liability. Right. Suppose in the service in the life cycle of the part, if there's some casualty on the ships, and the insurance claims, would that include liability of the manufacturing process?
Well, to address that, right, if let's say we do work on a part that's safety critical, definitely the class rules will apply. So there are certain steps and tests required for the part, whether it's coupon testing or sacrificial part, to sort of guarantee that the part will perform to a certain standard. And I do believe that guide does have some reflection on traditional manufacturing methods as well. So it would likely that AM part manufactured passes these tests would be as good as traditionally manufactured part, for example, casting or forging. Anyway, that's the objective, to make sure that both streams of manufacturing would be as good as each other.
Okay, so if there's insurance claims, right, for related to a casualty of the suffered by a ship, so that means, are you saying that the claims would have a way of leading all the way back to the manufacturing process, and the AM manufacturer can be held liable? Would that be possible?
I would say that whether it's a traditional or AM part, both would follow the same investigation procedures, and whatever liability has to be enacted. Yeah, we don't see both parts operating differently. So if let's say it's true for case A, case B, it would apply. Yeah.
Okay, maybe just one more last question about liability. So from the manufacturer perspective, do you impose a limited liability in this case?
Limited liability. Well, I would say it depends on the part. It really depends on the part. If let's say it's a high critical part, of course we assign the correct level of compensation or liability to it. If let's say it's a non-critical part, then the same tiering will apply.
Okay, yeah. So a ship owner that purchased an AM part would be would know of such a liability or limited liability.
Yeah, and anyway, that's what we are trying to promote with the industry end users, to have the same confidence and to treat AM parts as good as traditionally manufactured parts.
Okay, thank you.
just wanted to check if there are any questions on Zoom. Okay. I think I have more questions for y'all if y'all don't have any questions. I noted that you mentioned there's some challenges in adopting a digital warehouse. Yeah, so maybe you could elaborate a little bit on what these challenges are. And yeah, because I understand it's also something that involves a lot of stakeholders. So maybe you could also share how we could like bring all the stakeholders together to kind of work on this. Yeah.
Maybe I share a bit. Okay, so digital warehousing can be very elaborate. Okay, storing design files, data is one thing, but working from different users or profiles of part requires different attention to different parts. Okay, it sounds a bit complicated, but in essence, an impeller, for example, would have different inspection or qualification requirements compared to, let's say, an engine piston. Yeah, because they have different criticalities, different standards apply, even materials that they use have different standards. So it's actually a whole universe of data that could be captured. So how do we smartly capture the correct data so that we don't start to inflate? You know, it gets very messy very easily if, let's say, we start to conflict all the requirements to certain profiles of parts. Yeah. So there needs to be a smart system of assigning the right standards to certain parts, certain materials, under certain operating conditions and in different parts of the vessels. Yeah.
Yeah, sure. Go ahead.
Yeah, so maybe just want to point out one thing that Daniel mentioned about complication. So I think that is why, as a class organization, we are very interested to look at this area, because we do see that from an industry perspective, there's a lot of factors that's complicating the entire process. However, there is no relevant standards or framework, or maybe there are, but it's progressing. It's probably not mature enough. It's probably still under development. So that's why we're going to come in to help some of these solution providers look at how can we make this into something that the industry will accept. May not be a standard right from the start, it may be a guide, but at least we try to holistically look at this as one single problem instead of like different problems happening together. But of course, that itself is very complicated. So now we can look at work packages, different work packages to look at different areas. But essentially, the whole idea is, as an approval and certification body, we really want to step in to look at some of these things that's happening, that's new, that actually addresses this challenge statement. And then together we develop some framework or guide to address this. Yeah.
Okay, so actually you have spoken a lot about the problem statement and also given a lot of context, stakeholders who are involved. Just wanted to ask on behalf of the startups, what can they expect to gain when working with you? What kind of support can they look forward to getting? Yeah.
Maybe I will start. Okay, so I think ABS is a classification society. So we are very much involved in the maritime industry. We can bring a lot of industry perspectives and industry experience and knowledge that can help the startups refine their solutions. That's one. Secondly, we definitely can provide the necessary network. If let's say the startups are looking for certain end users to take up the solution, it could be ABS ourselves also, depending on what's the nature of the solution. We definitely can also provide the necessary networking. And I think last but not least, if let's say the solutions are something that ABS thinks that it's really addressing a certain problem that we've identified, I think it also makes a lot of sense for us to then work on the project together to try and develop some of these solutions moving forward. I mean, no promises, but I think that's some of the things that I can think of.
For us, we do produce parts that eventually work on board a vessel. So if any startup wishes to sort of trial that solution through one or two workflows, that's very possible. We can do that. And of course, we can work with ABS also to see, for certain profile of parts, what sort of criteria or certification requirements are there. Then we can weave it into our process. Yeah, so we can offer trials, we can offer industry contacts who will provide feedback. So we do work with a group of end users who are willing to try AM and new solutions. So they're very forward thinking, and all these startups, they will be keen to sort of bring them in and just to try. Yeah.
Okay. Yeah, sure.
So I think for Piers Anyone, one of the unique factor is Today, like for example, Daniel and myself, rather Wilhelmsen and ABS, we are independent bodies. But then because of PS21, we're able to sit down together to look at very similar challenge statements. So I think as startups, when they come on board, they also are able to be exposed through one challenge statement, two perspectives from the industry. So Daniel definitely covering the commercial aspect. We are covering the approval and certification aspect. And then through the feedback from two different organizations, I think the startups can then also further refine their solution from that perspective. Yep.
Okay, thanks for sharing. So are there any further questions from the ground? Okay, if there are no further questions, I have one final question for you. So maybe could you quickly summarize in maybe 3 sentences on what you are looking for in the solution? I know you did mention like cybersecurity, traceability, but it could be good to give like a summary to wrap things up.
So ABS will start first.
Everyone get a turn.
Yeah, okay. I know we spoke of a lot of things. In summary, I think the key point here is today we recognize the current quality assurance process to be very time-consuming and cost ineffective. So we are looking for any solutions that can actually help to reduce the cost and the time to eventually getting parts approved by, for example, ABS.
I'll just add one more. So for us is how do we make sure that a physical part will have the same characteristics as a digital part? I mean, pinning that down, I think would be one part of the holy grail that we can achieve. Yeah.
Yeah. So actually, thank you for your time today. I think we are coming towards the end. So for startups who are listening in, who are also here, we encourage you to put forth proposals, and it will close on 8th of July. But of course, put in earlier is better. So we have time to kind of reach out to you if anything can be further added on to support your application. Yeah, so okay, so we're on the next slide. So yeah, just remember our deadline is 8th of July. You can scan the QR code to apply. And if you'd like to find out about other innovation opportunities, you can also scan the other QR code. Yeah, so moving on to the next slide, please. Yeah, so we also have other roadshows, and the upcoming one will be PSA this Thursday. And we have more roadshows next week with Clapners, Jurong Port, Wilhelmsen, OMC Shipping. So do sign up for those as well. Yeah, and also please continue to follow us on our LinkedIn and social media where you can get the latest updates. Yeah, so thank you everyone, and see everyone who is on Zoom soon. Thank you. Oh yeah, now we can begin the informal networking session. Yeah.